Okay, so up till now, we've dealt with the basic derivative rules. So we started off with, actually, let's go to writing mode. Whoop, nope. Okay, fail again. There we go. Up till now, we've done things like, okay, oh, why is it always a setup? How do you calculate the derivative? By taking the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. So this is called the limit definition of the derivative. Okay, the only problem with it is that it's really slow and intensive to use. Like, nobody wants to use the limit definition for the most part. So instead of doing the limit definition, we started looking at the derivative rules. What sort of rules did we look at? Things like, A, how do you take the derivative of a constant? How do you take the derivative of the identity function? The power rule. You know, taking the derivative of x to the n. The sum and difference rule. The product and quotient rule. Right, so we have all these derivative rules that basically sped up the process of taking derivatives. And, you know, we could write them if we wanted to, but whatever. So, I want to look, there's like a difference between 1, 2, and 3, and 4, 5, and 6. So 1, 2, and 3 are how to take the derivatives of like particular things. For instance, the constant rule is how do you take the derivative of a constant? Well, you get 0. The power rule is how do you take the derivative of a power, x to the n? Well, we know it's n times x to the n minus 1. Okay, 4, 5, and 6 are slightly different. You can sort of call them meta rules. They tell you how to mix and match functions. And we left out the constant multiple rule. So what do I mean by mix and match functions? Well, for instance, the sum and difference rule tells you, let's say that you want to take the derivative of the sum of two functions. You don't know exactly what those two functions are, but if you are adding two functions, what you can do is just add their individual derivatives, right? Oops, I didn't put g properly. Okay, so notice you don't know what rule you would be using to take the derivative of f or the derivative of g. The whole point is that if you have two functions and you add them, this is something you could do with them. The difference rule is if you took the derivative of the difference of two functions, what could you do with it? The product rule is if you had the derivative of the product of two functions. The quotient rule is if you had the derivative of the quotient of two functions. There's actually one more function operation that's missing here. You can add functions, subtract functions, multiply functions, and divide functions. Does anyone remember what the other function operation that we're missing from this list in 4, 5, and 6 is? So does anyone remember what the other function operation other than adding, subtracting, multiplying, and dividing is? Let's see. Oof. Do we happen to remember? It starts with a C. Curious if anyone can remember or guess. Well, the chain rule is a derivative thing, but what is this called? Here, let me write it. When you write f of g of x, what is that called? There's a name for this. Almost. It's a composition. Very, very close. So, or what we say is we say that they are composed. So So composition is when you make one function the input of another function. Okay, so this is a function operation, just like how you can multiply functions, just like how you can divide functions. So we call composition a function operation. So we need a rule that will tell us, hey, if you want to take the derivative of the composition of two functions, what do you get? This rule is called the chain rule. Okay, the chain rule is, so just like, it's sort of weird. You should call it the composition rule, but we call it the chain rule. Alright, so it's called the product rule because it tells you how to take the derivative of a product. This should be called the composition rule because it tells you how to take the derivative of a composition. Instead, we just call it the chain rule. Okay. So to let you know, there's two different versions of the chain rule. There's two different ways to write it, so we're going to cover both of them. So this is an important thing to remember. There are two different ways to write the chain rule. You'll need to know how to do both. Why do you need to do both? Because in later classes, like in physics or later math classes, sometimes it's easier to write the chain rule one way as opposed to the other way, and sometimes it makes it easier to perform calculations and to think about things. So one way of writing it is more useful in various cases compared to another way of writing it. Okay, so I know that usually when you learn two ways to do something in a class, everyone's always like, oh, do I really need to know how to do both of them? The answer is yes. You do need to know how to do both of them. So, sorry about that. Or sorry, not sorry. Okay, so let me show you how the chain rule works. So let's say that you're taking the derivative of f of g of x. The chain rule tells you take the derivative of f and leave g inside of it, and then multiply by the derivative of g. Okay, so when you're doing these problems, you first need to identify your outer and your inner function, because it's a composition. One will be outside, one will be inside. So notice, to take the derivative, the chain rule basically tells you, hey, take the derivative of the outer function. And then you're still going to compose it with the inner function. And then what are you going to multiply by? The derivative of the inner function. Okay. So I'll show you how to actually do this in a moment, but I just want to point out that there are basically two different sets of parts that you need to be aware of. You're going to need to identify this outer versus inner function. I like to call them outer versus inner because sometimes they may not be called f and g, but usually we'll call f the outer function, we'll call g the inner function. Okay, so let me give you an example. Let's do a good one. Okay. Let's say that you want to take the derivative of 4x plus 3 to the fifth. Okay, looking at this, what rule would you like to be able to use to be able to take the derivative of this? Like what rule do you already know of that it looks sort of similar to? Yeah, right. It looks sort of like the power rule of x to the fifth, right? Which would be 5x to the fourth. But the problem is, you see how like you have this whole thing, the 4x to the third is being raised to the fifth? So what you have here is actually a composition. The outside function, the last thing that you do, is raise stuff to the fifth power. The inside function that you're going to pass into there is 4x plus 3. And what I highly recommend you do is that to identify these, make sure that f of g of x actually ends up being equal to what you have over here. So that means you're going to do f of 4x plus 3. Now what does f do to its inputs? It takes the input and raises it to the fifth power. So do you see how the f that I identified and the g that I identified, when I actually compose them together, like what I just did, you get the thing that you're taking the derivative of. So I've successfully identified my inner and my outer function. Okay, I'm going to pause for a moment. Do you remember doing this in pre-calculus? They would like give you a function and you'd have to write it as the composition of two other functions. Does anyone actually remember doing that in their pre-calc class? Is this like, what? Oh shit. They should have. Oh damn, okay. I feel bad for you then. Because yeah, that's like one of the things that like, I'm sort of assuming you're able to do. So questions about how I did this then. They have you practice that because like basically so that when you show up right here, right now, you'd be able to do this. Like, does it make sense? You go basically you go by the order of operations. Do you see how the last thing that you would do is raise stuff to the fifth power? That's how you know that your outer function is going to be x to the fifth. And then you ask yourself, what am I raising to the fifth power? Well, that's the 4x plus 3. That's how I got my inner function. Okay. Now, the chain rule says you need to know what f prime and g prime are. So you ask yourself, well, what is f prime? If f is x to the fifth, f prime is 5x to the fourth. If g is 4x plus 3, your g prime is 4. So the chain rule, so take the derivative of this. The chain rule says you're going to do f prime of g of x times g prime. So you start filling things in. Well, what am I going to put into f prime? I'm going to put my g prime, my g is 4x plus 3. And then I need to multiply that by g prime. My g prime is 4. Where do these come from? Just right above in green, right? Okay, now f prime is 5x to the fourth, and its input is 4x plus 3. So I'm going to do 5 times 4x plus 3 raised to the fourth power times 4. So looking at this, does it make sense that the stuff in blue comes from the fact that f prime is 5x to the fourth? It's going to take its input, which is 4x plus 3, raise it to the fourth power and multiply by 5. And then that 4, the times 4, comes from the g prime. And then you can simplify everything. You get 24x plus 3 to the fourth. Notice it sort of looks like the power rule. You started off with a fifth power, and what do you end up with? Oops. You started off with a fifth power and end up with a fourth power, right? Remember how when you take the derivative, the power basically goes down by 1? Okay, so the chain rule allows you to Like normally you could only take the derivative of x to the n. Now this allows you to do like any arbitrary function raised to a power. Okay, so I'm going to pause for a moment. And see if there are questions. Are there any questions on how I identified f and g? Mm-hmm. Mm-hmm. Because are you talking about like basically here, right? Okay, cool. So notice the chain rule says it's f prime of g of x, right? So it's not f prime of x, it's f prime of g of x. So wherever there was an x here, you need to replace it with 4x plus 3, right? So you get 5 times 4x plus 3 to the fourth, not 5x to the fourth. Mm-hmm. Yeah, that throws people off a lot, to be honest. You get that complicated thing in there because the composition in the chain rule. Other questions about identifying f and g, figuring out f prime or g prime, plugging it into the formula. I pick my nose. Alright, I'll do another, how about I'll do another one, and maybe like, that will give you another question. Or a slightly different example might give you might raise some questions. Okay, so let's say that you're taking the derivative of sine cubed x. So really when you're looking at this, that's the same thing as taking the derivative of sine cubed. Does that make sense that those two things mean the same thing exactly? So here's my question. What is the last thing? What's the last operation that you perform? The last operation should be your outer function. So what's the last thing that you do? Oh yeah, cubing it, right. So your f of x is x cubed. Now, what do you feed to the f of x? What gets composed into it? That's your inner function. Yep, exactly, sine. So now you can go and you can verify, hey, what is f of g of x? Well, g is sine. And what does f do to sine? Well, it's going to take sine and it is going to cube it, which we usually write as sine cubed x. And that's exactly what you're taking the derivative of. So we identified f and g correctly. Okay, so what does the formula say? If you want to take the derivative of sine cubed, the formula is f prime g of x times g prime. So I need to know what f prime and g prime are. Well, if your f is x cubed, your f prime is 3x squared. And if your g is sine, then g prime is cosine, and we talked about that last week. Right, so using the power rule and the trig rule. So what do? Well, you start going and plugging things in. I need f prime of g. What's my g? My g is sine x. And then I need to multiply by g prime. My g prime is cosine x. What is f prime? Well, f prime is 3x squared. So I'm going to have 3 something squared. The thing that I'm squaring is sine, and And then this is going to be multiplied by cosine. You can now go and simplify, and we get 3 sine squared cosine. So I'm going to leave this here for a minute to let people look at it, see if there are any questions you want to ask about any of the parts. Identifying f and g, the f prime and the g prime, seeing if f of g, if the composition is what you're taking the derivative of, the formula itself, plugging the stuff into the formula. I'll sit for a moment. Okay, let's do another one. Okay, so let's say that you wanted to take the derivative of the cosine of g of x. Okay, this one's actually sort of interesting because we've already identified our inner function. But what's the outer function? What is our f of x in this case? What's the last thing that we do? No. Yeah, you take the cosine of g of x. The inner function is literally just g of x. Because the way it works is you start inside. The x goes into g, and then all of that goes into cosine. The last thing you do is the cosine. Okay, now the chain rule tells us that we're going to have to do the derivative of the outside function of g of x times the derivative of the inside function. So I need to know, well, what's the derivative of my outside function? My f prime is minus sine. The derivative of my inside function is just g prime. Okay, so what is f prime going to do? It's going to be the minus sine of the inside function. The inside function is g of x. And then what am I going to multiply by? The derivative of the inside function, which is g prime. And this actually is my answer. The derivative of cosine g of x is the minus sine of g of x times g prime x. This is a little tricky because they didn't tell you what g of x is. So you just end up with these g of x's here. Like there's nothing to replace them with. So this is a very common sort of more abstract question sort of. So I'm going to pause for a moment. See if there are questions. Mm-hmm. I would put decomposing functions. And, let me just quickly talk about it. Because what you're doing is you're starting with some function, and you're decomposing it into two functions, f and g, so that the function that you started with is their composition. That's basically what you want to figure out how to do. They might not say those words exactly, because usually, maybe, I guess if the person is smart, they'll actually put that as the keyword, because that's what it's actually called. Okay. What it could be is writing a function as the composition of two functions. Might also be another thing to look up. Writing a function as a composition of two functions. And just to sort of tell you what's hard about it is that you need to understand the order of operations to do it well. Let me give you an example. Let's say that you're looking at the cosine to the 7th power of 3x minus 1. There's actually three different functions here. What is the last thing that you do? We're going to call that f. So there's three options here. 3x minus 1, that's one thing. Cosine is another thing. And the 7th power is another thing, which is the last thing that gets done. That's the outside function. No, that's the first thing. 3x minus 1, because you would first plug into x, and then you would get 3x minus 1. That would then get sent to cosine, which would then be raised to the 7th power. The last thing that you do is raising to the 7th power. Now, what gets sent to the 7th power? That's going to be your g. Yes. And then now, because there's a third function, we're going to have an h. What gets sent to the cosine? Yep. So sometimes you can break things up into three functions. Now you would check to see if you did everything right by going and calculating what is f of g of h of x. And then you would start making the replacements. So h is, yep. Now that's getting sent to g. What does g do to 3x minus 1? If you look at g, what does it literally do? Yeah, well, so you would do the cosine of 3x minus 1. Because notice what's getting sent into g here is 3x minus 1, not x. Now, the last thing we're doing is f. What does f do to anything? Yeah, exactly. So this is saying hey, take that stuff that you just had in there and raise it to the 7th power. Now, what was the stuff that you have in there? It's the cosine of 3x minus 1. Now, normally the way that we write this is we don't put the brackets around it. We just write cosine to the 7th power of 3x minus 1. These two things mean the same thing. But when you write it this way, it's way more obvious that the 7th power is last. Just people are lazy. No one wants to have to put those brackets or parentheses around it, so we just usually write the 7th power right here. Okay, so that's why they covered this in your pre-calc class, so that when you got to something like this, you'd be able to decompose your functions. Because you need to be able to identify your inner and your outer function for the chain rule, basically. Alright, let's do another one. This one's going to be a more complicated example. We're going to use several rules at once. We are going to take the derivative of 2x plus 1 to the 5th times 3x minus 2 to the 7th. Okay, what's the last rule that we're going to have to use here? Or the first rule, like the last operation. The first rule is the last operation. So I'm going to give you a little bit of a hint. If you look at this, what's it telling you to do? Yeah, exactly. So you have to use the product rule on this. The product rule says take the derivative of the first thing, 2x plus 1 to the 5th, and then multiply it by 3x minus 2 to the 7th. And then add to it where you leave 2x plus 1 to the 5th. And then what are you going to multiply by? The derivative of 3x minus 2 to the 7th. Okay, so your first step here is because your last operation, you basically start with the last operation. The last operation is multiplying, which means you will use the product rule. So now we have the product rule set up here. Let's just write that down. Okay, now looking at these derivatives here, what rule are you going to have to use for them? Like for the derivative of 2x plus 1 raised to the 5th power, or 3x minus 2 raised to the 7th power. Not the exponential rule, not the power rule. You would do it if you had x to the 7th or x to the 5th. Notice we're feeding in something into that 7th power and the 5th power, so you can't use the power rule. What do you use instead? That we just learned. We're going to use the chain rule. So for this one over here, we'll identify our f of x. What is the last thing that happens in what we're taking the derivative of here? What is my outside function? The outside function is, it's the last operation that happens in this area here, in the thing that I'm taking out the derivative up here, the derivative of 2x plus 1 to the 5th. What is the last operation? How's everyone doing? Are our brains dying, or? Okay, I will go through. The last thing we do is x to the 5th. Now, what gets fed into that x to the 5th? That's our inner function g. That's the 2x plus 1. So to use the chain rule on that, we take the derivative of x to the 5th, which is 5x to the 4th, and we're going to need the derivative of this one, which is 2. And I have to do the same thing for the one over here, because we're taking two different derivatives. The last thing that we do is raise something to the 7th power. What gets fed into the 7th power? Our g of x, which is 3x minus 2. To use the chain rule, we had to calculate f prime, which is 7x to the 6th. And we have to calculate g prime, which is 3. So now what we need to do is use the chain rule. Okay, so to use the chain rule, the derivative of 2x plus 1 to the 5th, we're going to need f prime of g of x times g prime. And then that's going to be multiplied by 3x minus 2 to the 7th. And then you're going to have 2x plus 1 to the 5th times, again, f prime g of x times g prime. And now what we need to do is plug those things in. So let's simplify the chain rule part. So we're going to do f prime of our g of x is 2x plus 1. And we're going to multiply that by g prime, which is 2. Now f prime is 5 raising your power to the 4th. So what's being plugged into f prime? The 2x plus 1. And then you're multiplying that by 2. Which is going to give us 10 times 2x plus 1 to the 4th. That is what all of this became, and there's the work for it. Okay, what is that going to have to be multiplied by? 3x minus 2 to the 7th. You're going to add to that 2x plus 1 to the 5th, and then we have to figure out what all of this here is going to be equal to. So we're going to have f prime of, now our g of x for that problem is, or for that part is 3x minus 2. And then we're going to multiply that by g prime, which is 3. Now f prime in this case is 7x to the 6th. So we're going to do 7 times that stuff raised to the 6th power. Well, the stuff that we're raising to the 6th power and multiplying 7 by is 3x minus 2, and that's going to be multiplied by 3. So you multiply those together, 7 times 3 is 21, 3x minus 2 to the 6th power. This is your derivative. This is equal to the derivative of 2x plus 1 to the 5th times 3x minus 2 to the 7th.